ಇಲ್ಲ ನೆನ್ನೆ ಆಯ್ತು. ಇಲ್ಲ ಅದು ಯಾಕೋ ನೆನ್ನೆ ಮೇಲ್ ಬಂದಿತ್ತು, ಲಿಂಕ್ ಇತ್ತು, ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಆದಕ್ಕೆ. ಅವ್ರು ಟ್ಯೂಸ್ಡೇ ಅಂದಿದ್ರು. ಇವತ್ತೊಂದು ಏನೋ ರೀಸನ್ ಇತ್ತಪ್ಪ ಮೇಲಾಗ, ನಾನು ನೋಡ್ಲಿಲ್ಲ, ಕ್ಲಾಸ್ ಅಷ್ಟೇ ಅಟೆಂಡ್. ಅದಕ್ಕೆಲ್ಲ ಮತ್ತೆ ನೆನ್ನೆ ಬಾದ್ ಹೋಗೋಣ ಅಂದಿದ್ದಕ್ಕೆ ಇಲ್ಲ ನಾನು ಬರಲ್ಲ ಲೇಟ್.
Yeah, so hi, hello everyone. So you'll just start the session in just a while. Can you just confirm if my audio is audible to you?
Yes, sir, you are audible.
Okay, thanks very much. We will just start in 2-3 minutes.
Okay, sir.
ನಾನು ಅದೇ ಅಂತಿದ್ದೆ ಏನು ಏನ್ ಮಾಡೋದು
ಸ್ನಾನ ಮಾಡೋದಾದ್ರೆ ನೀರ್ ಕಾದೋಗಿದ್ದಾವೆ.
ಟೊಮೆಟೊ ಹಾಕ್ತೀನಿ ಬಟ್ ನನಗೆ 1% ಇಷ್ಟ ಆಗಲ್ಲ ಟೊಮೆಟೊ. ಪುಲಾವ್ ಸೊ ನಾಟ್ ಟೊಮೆಟೊ.
Yeah, can you confirm if my screen is visible?
Yes, sir. Screen is visual.
Okay, thanks. Okay, so we will just get started. So hello everyone and good evening. Welcome to week number 2 of the problem solving session for the course on Introduction to Electrical Engineering. So I presume you would have seen the lecture videos for week 2, right? So wherein you covered RC and RL circuits, and you also went through step response, impulse response, and studied about series RLC circuits, parallel RLC circuits, and so on, right? For different kinds of input voltages or different kinds of inputs. So how do you determine the output parameter? Correct? That is the current in your circuit or voltage across the capacitance and so on. So as usual, we'll be solving a few problems, right? So before we jump into that, we will just complete the problem that we were seeing in the last class, right? That is this particular problem, correct? Yeah. The resistance should be connected across terminal AB for the circuit shown in figure below, which will draw maximum power from the rest of the circuit. So of course, this is a problem that is based on the principle of maximum power transfer, right? The resistance is to be found out, correct? So obviously, the answer will be the Thevenin resistance that you need to determine, right? So,
ಇಲ್ಲ ಎಲ್ಲ ಫುಲ್ ಮುಗಿಸಿ
Yes, sir. Right.
sorry.
Oh, sir, excuse me, sir. Oh,
Yeah.
in the only first slide we can see there is no problem here.
Oh, you are able to see only. So
First
is my
slide, sir.
screen visible?
No, sir. Screen is visible, but there is
Okay.
only first slide showing. That is NPTEL Introduction to Electrical Engineering. There is nothing
This slide,
No,
second
sir.
slide
No, sir.
for everyone else.
All
We only
slide
see
is,
the first slide.
no, sir. All
First
slide is
slide is
visible.
visible.
Visual this. First problem visual is.
Visible, right?
Yes, sir.
I think you can log out once and log in again. I think that would fix the problem. I don't know. These problems generally do occur, but yeah, you try to log out once and log in again. Okay. So as we were telling, we have to find out the Thevenin resistance, correct? So to find out the Thevenin resistance, what do we do? First, we have to disable the independent sources, right? So if we have to disable the independent sources, first thing is we have to short the voltage sources and open up the current source. Okay. So of course, this will be shorted. This will also be shorted, and this will also be shorted. Okay. So now you can draw the equivalent circuit, which means that we have point A over here. 30 ohms. Again 30 ohms. Right? So this is 48 ohms. So 20. Oh, 20. Oh, 20, and then you have got a 10. Okay. So this is the equivalent network, right? Somebody's mute is on. Can you please unmute, can you please mute yourself? Hello. Okay. So then what do we do? Over here, you can recognize that there is a delta connection, correct? So you have a delta connection over here, right? And similarly over here, correct? So if you convert from delta to star, right? So you can convert this from delta to star, which means that you can have something like this, right? Okay. So what will be the equivalent star inside it? It will be, so for instance, right? For instance, if I take this particular resistor, right? This particular resistor, the resistor value will be multiplication of the resistors that are surrounding it. That is this resistor into this, that is 30 into 30 divided by 30 plus 30 plus 30. All right. So same for this resistor as well. Over here, you just see the resistors that are enclosing it. So 30 into 30 divided by 30 plus 30 plus 30 and so on. Okay. So that is how you solve this problem. So what you do is you go over here, 10 ohms, and you again have 20 ohms. You have 6 ohms. Okay. And now what we have is the equivalent of the star connection. Correct. So let me just erase this. Yeah. So then what I have is something like, so this resistor, and then there is one more resistor over here, and then there is this resistor. Okay. And similarly over here as well. So this is your A and this is your B. Okay. So what are these resistor values?
10 ohm, 10 ohm, 10 ohm.
Correct. So it will directly be 30 by 3. So it will be 10 ohm, 10 ohm, 10 ohm, 16 ohm, 16 ohm, 16 ohm. Okay. So again, this can be simplified further. So what you have is obviously 10 and 10 in series over here, right? And 6 and 16 in series over here. Okay. So let me add a new slide. So you have 20 ohms, and I think you were already having 20 ohms over here. Correct. You are having 20 ohms, and here you have 6 and 16, which is 22 ohms. Okay. So then what you are having is a 10 ohm resistor connected like this and a 16 ohm resistor over here. So you have 10 ohm, you have 16 ohms, correct? Okay. And then from the common point, you are having a 10 ohm and a 16 ohm. Okay. Yeah. 10 ohm and a 16 ohm. This is your A, this is your B. We want to see the equivalent resistance as seen from here. Okay. Okay. So now what we can do is, as you can understand, you are again having a delta connection, right? So what is the delta connection? There is a delta connection over here. Okay, you can either consider this or you can also consider this. There is a delta connection over here, this. Okay, so you can consider either of these as a delta connection. Okay. Okay. So so what we will do is we will redraw this just for you guys to understand. So I can redraw this as something like this. Right now it seems more apparently that this is a delta connection. Okay. So now this can be simplified as this, and this. Correct. This is the equivalent that we will try to simplify. Okay. So this can further be drawn as 20 ohm, 10 ohm, 10 ohm, right? And then what I'm having is I'm having a star connection. All right. After which I again have another resistor. Right. So this is the equivalent that we are now having. Okay. So what are the values of the resistors? Again, this particular resistor will be directly 22 into 20, which is the enclosing one, divided by summation 22 plus 20 plus 16. Okay. This particular resistor will be what? 22 into 16 divided by 22 plus 20 plus 16, right? And likewise the other one. So can you guys do the calculation and tell me, anyone? What are you getting? So this is 58. So I am getting
6.068.
so I'm getting 7.59 and yeah, so this is 6.07 and the other one would be so this is 5.52. All right. So now you can understand that this is in series. This is also in series. This is also in series, right? So we just again redraw the picture as something like we have 27.59 ohm, okay, and we are having again 15.52 ohms, okay, and then we have 22.07 ohms, right, and we have 10 ohms, okay. So now the answer should be pretty simple. So your RAB is equal to what? It is equal to 10 plus 22.07 plus 27.59 parallel to 15.52. Okay. So what is the answer? So I am getting 42 ohms exactly. Is this understood? Is the problem? It is just a case of star to delta transformation. Okay. Just identify the delta connections and accordingly you should give the you should simplify the delta to star and after that you kind of simplify the curve. Okay. Okay. So I think this is fine. All right. We will go ahead with the next problem. Right. So this is the R Thevenin or this is the load resistance that will draw maximum power from the circuit. Okay. Okay. So the next question is that same curve is given. Now they are asking what is the value of the maximum power drawn. Okay, what is the value of the maximum power drawn? So from the theorem of maximum power transfer, you will be knowing that some people would like to remember this formula directly. V Thevenin square divided by 4 into R Thevenin, right? But even if you don't remember, the simple way to kind of get to this answer is that since you have found out the R Thevenin, right? It means that you have a voltage source with this V Thevenin, right? And you approximated the circuit to be R Thevenin, right? This is what you do for any circuit. A, and this is your B. They have asked that what is the value of the maximum power? If maximum power has to be transferred, your RAB should be the same as R Thevenin, right? This will again be R Thevenin. Okay. So now you can understand that the maximum power, right? So this will be your I I will be what? I will be V Thevenin divided by 2 R Thevenin. Correct? This will be your I. Therefore, your power will be what? P max will be what? I square RL. Correct? I square into R load. That is I square into R Thevenin. Right? So V Thevenin by 2 R Thevenin the whole square into R Thevenin. Therefore, you will be getting V Thevenin square divided by 4 into R Thevenin. Okay. So this is the value of the maximum power. We know what is R Thevenin. We just computed it to be 42 ohms, right? So R Thevenin is 42 ohms. We just need to find out what is V Thevenin. If we find out what is V Thevenin, we will get the answer. Okay. We will get what is P max. All right. Okay. Let's go ahead. So now we just need to find out the V Thevenin that you would see from this end. Okay. What is your V Thevenin? All right. So again, we are having the same circuit. We just saw some time back that this is a delta connection, right? This is again the delta connection only. So I will just directly write this right. Right now I can just directly write it. All right. That this can be written as what? This can be written as 60 volts, 10 ohm, 20 ohm, right? And after that point, we converted the delta to star, right? So when we converted the delta to star, we saw that each of the resistances is only directly 10 ohms, right? 30 by 3. 10 ohm. This is also 10 ohm. And from that, after that point, you are having a 35 volts. You are having a 35 volts. All right. This is your A. And similarly, what you have over here is that you have 6 ohms. Again, there is a delta to star connection. So its equivalent is going to be 48 by 3 directly. 16 ohms. 16 ohms. 16 ohms. So this will be B. Correct. So we have already simplified these. Anyway, I'm just redrawing it only. Right. So 60 volts. So 10 and 10 in series is going to give you 20 ohms, right? This is again 20 ohms. This is 22 ohms. Okay. And then what you have is a 10 ohm resistor connected over here. There is a 16 ohm resistor that's connected over here. So from the output, you get again 10 ohms. This is 16 ohms. Correct?
Yes, sir.
Okay. So again, we do the same thing that I will redraw this in a different fashion. So the 22 ohm, I will redraw like this. So you can understand that this was actually a delta connection. So again, we simplify the delta to star. So we have already done it, right? So I will directly write the resistance values. So what were the resistances? We got 7.59, 5.52, 6.07. Correct? So Sorry. So this is what we simplify that 7.59, 8.52, 6.07. Okay. All right. So this can further be written as 60 volts, 20 ohms, correct? So, okay. It's 1.59. Excuse me. Okay. So one thing is that the 7.59 and 20 ohm are in series. Therefore, what I will do is I will directly write 60 volts, 27.59 ohms, and you are having 5.52. So 16 plus 6.07 is going to be 22.07. Okay, so this is the equivalent network. Someone's mic is unmuted. Can you please mute yourself? Someone is unmuted. Please mute yourself. Okay. So the question is that we have to find out the Thevenin voltage from seeing at this point. Okay. What is the equivalent voltage, right? So can you answer if will there be any current that will flow through the 10 ohm resistor or 16 ohm resistor given that VAB is open? Will there be any current? Yeah, sorry, this was This was 10 ohms. So if we see over here from the terminal of VAB, right? From the terminal of VAB, looking from VAB, we see that since VAB is kind of open, there will not be any current that will flow through the 10 ohm resistor. Correct? There wouldn't be any current that would flow through the 10 ohm resistor. Okay. However, you see that there is a closed circuit over here, right? So there will be a current I. Okay. So what will be the current I? Current I will be directly 60 divided by 20 plus 7.59 plus what? Plus 10 plus 5.52. All right. So there will be a current that is 60 divided by 20. This resistor, this resistor, this resistor, and this resistor. Okay. So can you tell me what would be the current? I am getting around 1.39 amperes. Okay, this is a current that flows into this circuit. Okay, so in order to find out what is the Thevenin voltage looking at this point, what is the KVL equation that we would write? KVL is basically so the KVL expression would be V threshold is equal to what? V threshold is equal to 35, right? Then there wouldn't be any drop across a 10 ohm resistor since there is no current that flows. Okay, and then there is of course your drop across your 10 ohm resistor, correct? So there is 10 into I, correct, plus 5.52 into I, right? And then no current is flowing through the 6.07 ohm resistor as well. Okay, so no drop over there, no drop over 16 ohm resistor, and there is your 15 volt, correct? So it is connected in negative polarity, for which I have to write this is minus 15. Okay, so what is the threshold voltage? What is the Thevenin voltage you will be getting? You will be getting 35 plus 15.52 into 1.39 minus 15, correct? All right. So any answers?
$41.57.
Correct. So you get 41.5. Okay. So now what will be your P max? Your P max is going to be what? V threshold square divided by 4 into R Thevenin, correct? So what is the answer? Are you getting this? Is this understood like how we are doing? So 41.5 square divided by 4 into, we found out that the R Thevenin is 42 ohm in the previous problem. Therefore, the answer is 41.5 square divided by 4 into 42. I am getting around 10.3 watts. Are you also getting the same answer? Is this fine with everyone? Is
Yes,
this
sir.
understood?
Yes.
So you
Yes, sir.
understood, right, how we are doing this? Simplification is one thing, you found out what is R Thevenin, right? But finding out V Thevenin, you have to make sure that, see, since you are seeing from the terminal of a VAB which is open, you understand that there will not be any drop across the 10 ohm resistor. There will not be any drop across the 16 ohm resistor because over here there is no current. Okay, no current is flowing over here. Therefore, there is no drop across your 6.07 ohm resistor. Whereas you have to consider the drop across this, you have to consider the drop across this. You understand, right? That is why we have written 35 plus 10i plus 5.52i, then directly minus 15. Okay, that is how you found out your V Thevenin. Okay, so I hope you understood this problem. There is no drop across the 10 ohm resistor because AB terminals are open. Okay, please understand this. Okay, okay. So I hope this question is also clear. Okay, so I'll just, if this is clear, we can go ahead to the next set of problems, right? That mostly focuses on week 2. So if you have any doubt in these two problems, you can ask now, or we can go ahead in these two problems, right?
We understand. Move ahead, sir.
Sorry?
We understand.
Okay, sure. Thanks. So we can go ahead with the next set of problems, all right? Okay, so this will be question number 3. Just hang on a second, I'll just take up. Yeah, okay. Okay, so before we go ahead with RL, RC, and RLC problems, there are some things that you need to understand that are characteristic of your um, circuit elements. All right. So if you take RLC, right? So what you understand is that R behaves as a resistance throughout your independent of your operation, right? So it gives a constant resistance. Like let's say you take a 5 ohm resistor, right? Ideally, the 5 ohm resistor will give you 5 ohms totally across your frequency spectrum. Okay, that is whether you operate the 5 ohm in a circuit for 100 kilohertz or 50 hertz, or you operate at DC or different frequencies, right? So basically you see that the impedance that is offered by the resistance remains the same, right? Your Z will remain the same, impedance will remain the same across your frequency spectrum, right? Whereas if you consider an inductor, right? You consider an inductor, you see that the impedance is equal to basically omega into L, where omega is your frequency, angular frequency, right? Or we also represent it as 2 pi into FL. So you see that there is a frequency component over here. So as frequency increases, you understand that the impedance offered by the inductor also increases. Okay, if your frequency increases linearly, your impedance will also increase linearly, right? Okay. One more thing is under steady state, right? What is under steady state? Under steady state means it is DC, right? So under DC, you would see that, so F is basically right now 0, right? F is basically 0, which means that your impedance is 0, correct? Your impedance is 0. If your impedance is 0, it means what? The element is not offering any impedance to the current that flows, which means that the element acts as though it is not there, right? The element acts as though it is directly a short circuit, right? So one thing is that an inductor acts as a short circuit under DC. Okay, inductor acts as a short circuit under DC. Right? Okay. And the third thing is, of course, for your capacitance, you would see that your impedance is 1 by omega c, which means that we are inversely proportional to the frequency, 1 by 2 pi fc. Correct? So, as frequency increases, your impedance decreases. Okay? So, under steady state, right? Under steady state, when your f is 0, you see that your z is theoretically infinity, right?
Hello, sir. Hello, sir. Voice is not coming.
Hi, are you able to hear me now?
Yes, sir. You are not. You are now out audible.
Okay, so okay, sorry, probably by mistake I muted myself. I'm not sure. Okay, thanks for telling me. Okay. So the question is determine the time constant for the circuit shown in the figure. I'm just drawing the circuit. Okay. So this is an RC circuit. So what is the time constant of an RC circuit? Can you tell? 25 kilo. So what is the time constant of an RC circuit? So time constant is what we call as tau, right? Right. So for an RC circuit, the time constant is R into C. You have to find out what is R equivalent and C equivalent for the circuit. Okay. So from this circuit, you understand that 25K and 35K are in series. All right. So I can write this as 50 picofarad, 6 kilo ohm, 40K, right? And 25 and 35 are in series, right? So 25 plus 35 is basically 60. So 60 kilo ohm. All right. So now you see 40K and 60K are in parallel. So I can simplify this as 50 picofarad, 6 kilo ohm, right? So what is the parallel of 40 and 60?
24.
Correct. So this is 24K. All right. So now we are having 24 and 6 in series, which means that we are going to get 50 picofarad and we have 30 kilo ohm, right? So what is your answer? R is 30K and capacitance is 50P. All right. So what is the answer for this? 1500. So kilo is 10 power 3, pico is 10 power minus 12. So which means into 10 power minus 9, right? And the unit is seconds, correct? So I can write this as 1.5 microseconds, correct? Because see, 10 power minus 9 is nanosecond. 1 into 10 power minus 9. 1 into 10 power minus 6 is microsecond. So basically I have done this only. Okay. Everyone understood this problem? Simple question, right? Just simplify the circuit, you get the answer.
Yes, sir.
Okay. Okay, great. So again, similar question. So yeah, this will be the fourth question. Determine the time constant for the circuit shown. So you have 50 volts, 120 ohms, 80 ohms, 12 ohms, 50 millifarad. Okay. So we just have to find out the time constant for the circuit. So how will you find out the time constant if you have? So first thing is we just need to find out the equivalent resistance and equivalent capacitance, correct? So that is what we saw. Tau is equal to RC. We don't have anything to do with voltages, especially independent voltage sources, right? So directly you can go ahead and you can kind of disable the independent sources. So If you have a current source, you can open it up, and if you have a voltage source, you just directly short it. All right. So that is what we will again do. Okay. So yeah. So what we can do is we directly short 50 volts. So what we get is 120 ohms in parallel with 80 ohms, 12 ohms, 50 millifarad. Correct? To find out the equivalent resistance. So what is 120 parallel 80?
48.
48. Correct. So this is 48 ohm. We have 12 ohm. We have 50 millifarad. Correct. So 48 and 12 are in series. We get 60 ohms and 50 millifarad. Correct. So tau is equal to RC is what? R is 60 into 50 milli, right? 3000 milliseconds or 3 seconds is the answer. All right. I think this is also again a very simple problem. Just you need to disable the voltage source. Okay. So we'll go to the next question. Yeah. So the question is, again, it's a numeric question. Determine the total charge, right? Determine the total charge transferred in Coulomb, okay? In Coulomb over the time interval 0 less than 10 seconds if I of t is equal to half t amperes. So the profile of I of t is given. Okay, that is how your current is going to vary with time. It is given that I of t is half t. Okay. So determine the total charge transferred in Coulomb over the time interval 0 to 10 seconds if I of t is half t. So what will you do? I have given you current. You have to find out the charge. How will you do? How charge and current are related?
Integrate.
Correct. So you have to basically integrate it, correct? Because you know that what is current? You basically know that I is equal to, don't tell Q by T, it is dQ by dt. Okay, change in charge. Actually, that is the definition. So from this, you kind of get that Q is basically what? Integral I dt. Okay. So this is your charge. Basically, we have to integrate, right? So this is one method of doing it. So your total charge is going to be what? Your time interval is between 0 to 10. T equal to 0 to 10. I of t is given as half t dt. All right. So half into integral t is basically t square by 2, 0 to 10. Right. So this is basically 1 by 4 into 10 square minus 0 square. Correct. So you get 25 coulombs. Agreed? This is one way of doing this. Or the other way would be you plot this. All right. So since the function is simple, you can plot it, or else you may not be able to plot it, right? If it's a sine wave or something, you have to integrate and get the answer. But since it's a simple function, we can plot it. So this is your time and this is your I. right? So they have given it as half t. So it is directly proportional to t, therefore it would be a straight line, right? Just that we have to take care of the data points. Okay, so this is 0, this is 10. So since they have given it as half into t, right? At 10, we will be getting 5 amperes. Okay, so likewise at 5 seconds, we will be getting 2.5 amperes. Okay, so this is just a straight line. So integration is basically just to find out the area. Therefore, what you can do is you just need to find out the area under this triangle. Okay, so what is the area again? Area will be your charge, right? That is half into base into height, which is half into 10 into 5, right? Again, you are getting 25 coulombs. Okay, simple question, right? Okay, so this is fine. We will go ahead with the next question. So the question is, the switch, the circuit shown in figure has been closed for a long time. Okay. So some switch was closed for a long time. If someone says that some switch has been closed for a long time, it means that till that time the circuit was in steady state. Because it's been a very long time, you assume t equal to infinity. So if someone says it's long time, it means that the circuit was in steady state. Okay. It is opened at t equal to 0. Okay. So from t equal to minus infinity to 0, it was closed, and at t equal to 0, I open it. Okay. At t equal to 0 plus, right? The current through the 1 microfarad capacitor is dash. So first of all, is my handwriting clear? Like, are you able to follow? Just I want to ask your, is this legible for you? Whatever has been written in the slide?
Yes, sir, you are right clearly.
Okay, okay, thanks very much. Okay, so I'll just draw the circuit and we will apply whatever we saw earlier, right? That is, we just saw some time back that, oh, that inductor under steady state means if under steady state or at a DC, inductor is short and capacitor is open, correct? So that is what we will remember in mind while solving these problems. Okay, so the circuit is as follows. So this is 10 volts. One ohm. So there is a switch over here. Okay. So the switch is this. Okay. This is the switch, and I'm opening the switch at t equal to 0. And I'm opening the switch at t equal to 0. Okay. there is a capacitor over here, which is 1 farad, sorry, 1 microfarad. And there is a 4 ohm resistor. Okay. So the question is that it has been closed for long, right? That is from t equal to minus infinity till 0, the switch was closed. Okay. So the question is, what is the current through the 1 microfarad capacitor when the switch is opened? Okay. So let's draw the circuit when the switch was closed. Okay. Okay. So when switch was closed, right? That is when t equal to 0 minus, that is before this event happens, right? Before the event happens, 0 minus, right? That is before the event has happened. So what is the equivalent circuit? So what is the equivalent circuit before the event has happened? Before the event has happened, the circuit 10 volts, 1 ohm, right? The switch is closed. You have a 1 microfarad capacitor and then 4 ohms. Okay. So the question is, what is the current through the capacitor? That is fine. So the question is, when the switch was closed, right? Let's assume the switch was closed for a very long time. So we are under steady state. Okay. So if we are under steady state, can you tell what will be the position of the capacitor? Capacitor will be what? Open or short? So under steady state, a capacitor is open circuit or short circuit? See, under steady state, capacitor is open circuit, correct? Hello? Am I audible?
Yes, sir.
Yes, sir, you are audible.
Okay, okay. So the point is that under steady state, the capacitor is a open circuit. Okay. So why is it so? You imagine, right? So let's say, okay, I will just take a new. Okay. Let's say you take a 10 volt source. Okay. You connect a resistor and you connect a capacitor, uncharged capacitor. Okay. So I want to check the voltage across the capacitor at after let's say a long time, right? After a very long time, I check the voltage across the capacitor. Can you tell what will be the voltage across the capacitor after a very long time? So will it be 10 or will it be 0 or what will be the voltage across the capacitor?
10 volt.
Yes.
10 volt.
So under steady state, what has happened? Under steady state, what has happened? Whatever was the voltage, right? Whatever was the voltage, the capacitor has charged up to that voltage, correct? So when capacitor was uncharged, right? So when capacitor was uncharged, right? So then what would happen? The capacitor voltage would have started to increase, right? That is your V of t would have started to increase as given by, you would have learned this 10 into 1 minus e power minus t by 2, where tau is equal to your RC. Okay. So your capacitor voltage was initially 0, then it slowly went on charging and it reached your 10 volts, correct? So at infinite time, you would see that your capacitor would be having the same voltage as your whatever is your supply voltage. Okay. So now let's take another case. So you have 10 volts over here. I have R. I have another R over here. Okay. I connect a capacitor across this R. Okay. Under steady state, right? Under steady state at infinite time, what will be the voltage across this? So same R. I have R. I have R. Okay. What you take any value, no worries. Same R. What will be the voltage across the capacitor?
0.
See. Okay, so you forget that the capacitor is not there. Okay, you forget that the capacitor is not there. What is the voltage across R?
5 volt.
Correct. So this is 5 volt, right? This is 5 volt because R and R. Now what I do is I connected a capacitor over here. Okay, and I want to know the voltage at infinite time. Okay, at infinite time, what will be the voltage at infinite time?
5 volts.
See, correct, exactly. So it is only 5 volts. So as far as the capacitor is concerned, right, whatever is the voltage over here, at infinite time, it will charge up to that voltage, correct? So as far as the capacitor is concerned, it is seeing only this resistor and there is a voltage source of 5 volts over here for the capacitor. Okay. So the voltage is directly 5 volts. Okay. It doesn't care what is the voltage supply at 10 volts, what is the value of this resistor and all. Across its terminals, it will see what is the equivalent circuit that's able to see what is the voltage that is getting impressed, right, across its terminals. That is what is the characteristic of a capacitor. It will charge up to the voltage that is available. Okay. So this capacitor will charge up to 5 volts, right? The capacitor will charge up to 5 volts. So I think you can understand, right? This is 5 volts. So now let's go back to our problem. Yeah. So over here, we are having a capacitor across this 4 ohm resistor. So can you tell me what will be the voltage across the capacitor? Let's call this VC. So what is VC? Under steady state?
8 volt.
Correct. 8 volts. So just see the polarity. It is plus minus. Therefore, it should be minus 8 volts. Correct? Because why is it so? Because it is VC is basically what? Minus 10 into 4K minus 10 into 4 divided by 4 plus 1. Correct? That is equal to minus 8 volts. Okay. So VC is minus 8 volts, which means that the capacitor had charged up to minus 8 volts. It is having an initial charge of minus 8 volts. Okay. You got it right. The capacitor has an initial charge of minus 8 volts. Okay. So now the question is, what is the current when the switch is opened? Okay. So let's draw the circuit. When switch is opened. Okay. So again, you're having 10 volts. So you have 1 ohm over here. The switch is now open. Okay. There is no connection. You again have a capacitor. What is a capacitor? 1 microfarad. And then there is a resistor of 4 ohms. Okay, now the switch is opened. But what is the stored charge across the capacitor? What is the stored voltage? What is the voltage?
minus
Exactly. So there is a voltage of minus 8 volts over here. Okay. So now the capacitor kind of acts as a voltage source. It will dissipate and slowly it will lose charge. The voltage will decrease. But the question is, at t equal to 0 plus, at just the instant where you open the switch, right? At the instant where you open the switch, at that instant the voltage across the capacitor is minus 8 volts, right? VC is minus 8 volts. So what is the path for dissipation? The only path for dissipation is through the resistor because the switch is open, right? So what is the current? Current is basically 8 divided by 4 ohms, right? 8 volts, and there is a 4 ohm resistor, okay, which is 2 ampere. Did everyone get this problem? Did you guys get it?
Yes, sir.
And of course, the current would decay something like how much? Current would be I naught into e power minus t by tau. That's how the current would decay, right? So I naught is basically 2 amperes, that is 8 by 4 into e power minus t by tau. Tau will be what? RC, that is 4 micro, 4 into 1 micro. Okay, this is how the current would decay. It would decay like this from 2 amperes. You got it right? Did you understand what is happening? Once the switch is opened, you see the circuit once again. So when the switch was closed, right? This was the equivalent circuit when the switch was closed. Under steady state, the capacitor acts as an open circuit. Forget that the capacitor is there. You see that the capacitor would have charged up to minus 8 volts, right? Based on just the circuit parameters, 1 ohm and 4 ohm potential division rule. Okay. So the capacitor is charged up to minus 8 volts. Then what happened? You opened up the switch. So there is no contact over here. So minus 8 volts is the charge, or the minus 8 corresponding to minus 8 volts. There is a charge across the capacitor. So the capacitor acts as a voltage source, right? So this capacitor will discharge across the 4 ohm resistor. Therefore, the current, peak current, or the current when you just open the switch, right? That would be directly 8 divided by 4. All right. So the current is 2 amperes. Okay. Did you understand this, everyone?
Yes, sir.
What we are doing? Got it right? Okay.
Yes, sir.
If you have any doubt, you please ask. Okay, like most of the questions or problems are based on this principle. What will happen if the switch is closed and switch is open? Okay, so please understand how we are solving this. Okay, so we will go to the next question. So this, I guess, is question number 7, right? So in the network, shown in figure, the capacitor has an initial charge of 20 coulomb. Okay. Find I of t after 2 seconds of closing switch S. So I have a circuit as shown over here. Okay. So there is a switch over here, and 2 ohm. .5 farad. This is the switch S. And what is happening is I'm closing the switch. Okay. I'm closing the switch. And what I have told is that there is also some charge across the capacitor. Okay. There is also a charge across the capacitor. Find I of t 2 seconds after closing the switch. Okay. Find I of t 2 seconds after closing the switch. Okay. Okay. So let's simplify this problem. Okay. So they have given that Q is basically how much? Q is 20 coulombs. So you know that the capacitance is 0.5 farads. So what is the voltage? Initial voltage across the capacitor? What is the initial voltage?
0 volt.
V is equal to what? What is the relation? Q is equal to CV, right? So V is equal to Q by C. Correct? That is 40 volts. So there is an initial voltage across the capacitor of 40 volts. The capacitor is initially charged up to 40 volts already. Find I of t 2 seconds after closing the switches is the question. Okay. So just redraw the figure. Okay. So that you can understand it. Okay. So you have 120 volts, right? The switch is closed. So directly I am shorting it. And there is 2 ohm. There is the capacitor 0.5 farad. And there is also a voltage across it. Right? Let's draw this as, okay, or I will represent it in a different fashion. Something like this. Correct. 40 volts. Okay. So this is just the initial voltage. Okay. This is not a voltage source that is continuously 40. Okay. So take care of this. So this is just the initial voltage. It's not continuously there. Obviously, the voltage would kind of decrease from 40. Okay. As you close the switch. Okay. So just hang on for a second. I'll be back. I will drink some water and come.
Hello, Abhishek P. Abhishek P. Hello, Abhishek P. Abhishek. Abhishek P. Are you listening?
Noda Sanju, I'm not listening.
Hello, Abhishek. Are you in listening? Are you listening? Are you listening? Chillman? Are you understand the problem?
No man, teach me once again.
Okay. First, the battery was connection to the battery 120 volt. Okay. Next, put on 2 ohm resistor parallel to the capacitor 0.5 farad. Hello, Abhishek. Hello. Hello, Abhishek. Hello, Guten Tag. Hello, Abhishek.
Sir, you are not audible.
Okay. Sorry, I became muted. I'm not sure why. Uh, okay. Anyway, thanks for hanging around. And what I was telling is that in the middle, I heard some people were just making fun. But please bear in mind that this entire session is being recorded. Okay, and it will be uploaded on YouTube. So whatever no one is going to get penalized because of this and so on. But the point is, whatever you were talking, that would come on YouTube. So bear that in mind before you take other people's names.
Hello, sir. Sir, please share your YouTube
Sorry?
channel. Please
Sorry?
share your YouTube channel. YouTube channel say.
Yeah. So these sessions are supposed to be uploaded on YouTube, and it will be uploaded probably in a day or two. All of these sessions will be uploaded.
Okay.
Each week's lectures are uploaded, and I think you can also see the YouTube link from the spreadsheet document that the NPTEL admin has shared with you guys.
Okay, sir.
Oh, sir, I want to one query regarding recording of YouTube.
Yeah.
In the first lecture, there is no.
Yeah, so I saw that there was some problem, so I have deleted and re-uploaded it.
Okay.
I think you can. I did it today only. I noticed the problem, so I have re-uploaded it once again.
Or
Yeah.
in the first PPT, there is no solution provided in the first PPT.
No, I think
Yeah.
solution is provided.
I think I should show you the first PPT is not showing any solution. There is only question part. Sir, check it and revert back.
Sure. Okay. Okay, thanks for pointing it out. I will just have a look at it once again. Okay, fine. We will just continue over here. Yeah, so we were having this circuit, and you obviously know that the initial current would be 40 amperes. But after that, what happens? So your current would kind of decay, correct? So how would it decay? It depends on the RC time constant of your circuit. So what is your RC time constant? RC is basically 2 into 0.5, which is directly 1 second, correct? Correct. So this is your RC time constant. So you can directly write that your current is going to be what? Your I of t is going to be I naught into e power minus t by tau. We computed that I naught is what? I naught is 120 minus 40 by 2 ohm, right? Why 40 volts? Because the initial charge on the capacitor is 40 volts, correct? So this is 40 amperes into minus t by tau is 1, correct? So 40 into e power minus t is the current in amperes. So at 2 seconds, your current is going to be 40 into e power minus 2, right? So what do you get for 40 into e power minus 2? I'm getting 5.41 ampere. All right. So this is the current at 2 seconds. So first question, are you guys able to understand why it is I naught into e power minus 3 by tau? Why it is not I naught into, let's say, 1 minus e power minus 3 by tau or something? Are you understanding my question? How did you directly write that?
I didn't understand. Please explain this.
Sure. Yeah. So simple. So I will just take a basic example. From that you can understand any circuit that has RC with voltage source and so on. Okay. So let's take V, right? R and then C. Okay. So let's take some numbers for ease. So this is 10 volts. This is 1 ohm, right? And this is 1 farad. Okay, assume that the capacitor is totally uncharged. Okay, assume that the capacitor is totally uncharged. Okay, so you know that since the capacitor is uncharged, right, it is ready to take charge. Okay, it is ready to take more and more charge. Okay, so what will be the peak current through the circuit? What will be the peak current? Correct. So that will be directly 10 ampere. Now what happened? You imagine at one timestamp. Okay, at let's say at t equal to 0, right? At t equal to 0 plus 10 ampere current was flowing. Okay, 10 ampere current flow through the circuit. So once some current flows, what happens to the voltage across the capacitor?
10 volt.
So this is 10 volts, correct? Now this is 1 ohm. Now what would have happened to the voltage? There would be some voltage across the capacitor, right? The VC was initially 0, right? Now I would be having a VC1, which would be, there will be some voltage across the capacitor, right? Because some current has flown through it. Agreed?
Yes, sir.
Agreed? If I pass a current through a capacitor, the capacitor charges up a little. Therefore, there would be a voltage that is built up across the capacitor.
Yes,
Okay,
sir.
let's say this is now 2 volts. Okay, after some time it is 2 volts. I'm seeing now the voltage is now 2. Okay, so now corresponding to 2 volts, what will be the current? I1. What will be the current through the circuit now?
2 ampere.
How? See, there is voltage of 2 volts. Here there is 10 volts. So what is the current through the circuit?
8 ampere.
Correct. It would be 10 minus 2 divided by 1, which is 8 amperes. Okay. Let's say I take some other point. Okay. Now 8 ampere current was flowing through it. After some time, the capacitor is still continuing to charge, right? So this is 10 volts. This is 1 ohm, and I'm seeing at T2, time is equal to T2, right? Let's say the charge is now 5 volts. It has increased to 5 volts. What is the current now? What is the current? It is
5 amperes.
5 amperes. So you see, right? So initially 10 ampere current, then capacitor charges up. So the current becomes lesser. Then capacitor continues to charge up, the current becomes lesser. Okay. So now you understand, right? So as time goes on, right? As time goes on, as the capacitor continues to charge up more and more, as the capacitor continues to charge up more and more, the charging current is reducing 10 ampere, 8 ampere, 5 ampere. Now we would take the extreme case, infinite time, after a lot of time. Okay. After a lot of time, this is 10 volts, right? What will be the voltage across the capacitor? After a lot
10
of
volt.
time, what will be the voltage?
10 volt.
10 volt.
10 volts. So what will be the current? I infinity?
0.
Exactly, 0. Okay. So you understand that current is falling. Okay. You also know this is an RC circuit. How would the current fall? It would be an exponential fall. Correct? This is how the current will fall, because the voltage is rising up exponentially. The voltage, you understand, right? The voltage across a capacitor rises up like this. So the current would be falling again exponentially, right? You understand, right? It will fall like this. Okay. Did you understand this till this point?
Yes, sir.
Okay.
Yes.
Now we will go back to our problem. See, the capacitor has an initial charge of 20 coulomb. We found that corresponding to 20 coulomb, the voltage is 40 volts. Okay. So now where are we in the circuit? So we just map the same thing over here, right? That is, you are having how much? 120 volts. 120 volts, right? The switch is closed. You are having 2 ohm resistor. You are having a capacitor. We told that the capacitor voltage is 40 volts. We found out, right? Capacitor voltage is 40 volts and it is 0.5 farad. So now can you tell me what will be the current? What is the current at this point? I naught is how much? 120 minus 40 divided by 2. Correct? You understood this, right? How I naught is coming? The person who
Yes, sir,
asked the doubt,
understand.
are you understanding? Yeah. So this is 40 ampere. Now you understand that as your capacitor continues to charge up. Now what happens is the capacitor will continue to charge up from 40. After some time it will become 50, 60, 70, 80, 90, 100, right? And so on at infinite time it will reach 120 volts. The current will become 0. Okay, so the current again decreases, right? It's just an RC circuit. The current decreases because the capacitor is charging up continuously. You understand?
Yes, sir.
So I naught is 40 direct into, because the current is decreasing exponentially, directly e power minus t by tau. So tau is basically 2 into 0.5, which is 1. That is 40 into e power minus t. Did you get it?
Yes, sir.
Yes, sir.
Okay, this is the simplest way of doing this stuff. The other way would have been that you do the equation thing, right? That is, you write V is equal to IR plus this is basically what? This will be 1 by 3 integral IDT, correct? Plus there is some stored charge P of 0. Then what you do, you solve it, take Laplace and do on, right? That is how you find out what is I actually. But simplest part is you just apply your common sense a little. You know that capacitor is eventually going to charge up to the actual DC voltage that you are giving. So since the capacitor voltage increases, current decreases. How the capacitor voltage increases? It increases exponentially, 1 minus e power minus t by tau. So current will also decrease exponentially, that is e power minus t by tau, into whatever is your initial current I naught. Initial current is how much? Because I initially have 40 volts, they have given, right, 20 coulomb. So initially I am having 40 volts. So the current would be 120 minus 40 divided by 2. Right? 120 minus 40 divided by 2. That is the initial current into minus 3 by 2. Directly answer is done. Did you understand this question? Now the question is simple, right? Any doubt in this question, anyone? So can I move to the next question? Like, is this fine? Is this question fine?
Yes, sir.
Yes, sir.
Great, thanks. Okay, so you just understand this logic. You can solve a lot of problems with this logic. Okay. Okay. So we will move to the next problem. So just a second. I closed the problem. So the problem is, yeah. So the section figure has been in position A for a long time. Assume. So for a long time means it was in steady state, right? Assume the switch moves instantaneously from A to B t equal to 0. Find V for t more than 0, right? So the circuit is 40 volts, 5 kilo ohm. So I have A. This is 2 kilo ohms. Okay, so this is the switch. Okay, so now the point is I was initially with position A. Now I'm going from position A to B. Okay, so what is this type of switch? Have you heard of what is called SPDT, single pole double throw, which means that it is having a single pole over here, but it is having two throws. It can go either to point A, sorry, it can go either to point A or point B. So this type of a switch is called single pole double throw switch. Okay, with a single switch, I can go to either A or B, having my position fixed, right? So this is called, this is just some extra piece of information, a single pole double throw. Okay, SPDT. Okay, okay, so so the question is, I'm initially at position A and then I'm going to position B. Okay, so what is the value for V? Okay, how V would change? So before we go into numerical, can you try to answer? So what will happen if I am at position A, right? I am at position A, forget about B. It is just an RC circuit. Okay, 40 volts, 5 kilo ohm and 10 microfarad. So it is told that, okay, let's draw the circuit. Okay. So I'm at position. If I am at position A, it is just an RC circuit. All right. So I am at position A. So what is my circuit? $40 volts, 5 kilo ohms. I am at position A, so directly I can draw to 10 microfarad. Okay, you understand, right? This is position A and position B is not connected at all. Okay, not connected at all. So I have been in position A for a very long time. The switch has been in position A for a very long time. So what is the voltage V? What is V? What would be V if I have been in position A for a very long time? V infinity
40 volts.
correct. So the capacitor is completely charged to 40 volts. Okay. Now what I am doing, I am switching from position A to position B. Okay. So if I go to position B, what happens to the circuit? 40 volts, 5 kilo ohm, but this is now an open circuit. Now I have a connection between this and this 2 kilo ohm, 10 microfarad. This is my voltage. Okay. And initial voltage is how much? Initial voltage is now 40 volts. Let's call this V. Okay. Now he is asking how V of T would be. Okay, there is an initial voltage of 40 volts. Now this is just an RC network, right? Just an RC network right now. There is no independent voltage source. There is no independent voltage source to sustain 40 volts or anything. So 40 volts was there across the capacitor. Now it would start dissipating across the resistor, right? So slowly, as the capacitor discharges, what would happen? Slowly as the capacitor discharges, the capacitor would lose its charge. Eventually you will see that the capacitor will lose all of its charge and it will go to zero, right? Voltage will eventually go to zero. Are you understanding my description? Voltage was at 40 volts. Now slowly what will happen after some time, some charge will be dissipated to the resistor. Slowly it will go on getting dissipated and finally it will reach zero. So how can you write V of T directly? This is just an RC circuit again.
40 into
Can
e
we
to the
write?
power minus tau.
Correct. So directly we are able to write it, right? So 40 into e power minus t by what is tau? Tau is equal to 10 micro into 2k.
0.02
Okay.
seconds.
0.02 seconds. Okay, correct. So 0.02 can be written as 1 by 0.02 can be written as 40 into e power minus 50 t volts. Right? This is how the voltage will be decreasing. Are you understanding this, everyone? How I am directly writing this?
Yes, sir.
Yes, sir.
Great, great. Okay. Okay. So please just see the circuit. Don't just start writing your KVL, KCL equations. Okay. See the circuit and understand what's going on over here. You will see that the answer is much simple. You need not actually solve everything. Okay. Okay. So if this is fine, we will go to the next question, right? Again, a similar kind of question. Okay. For the circuit in figure, find I naught for t less than 0 in ampere. Okay. So what is the circuit? The circuit is that they have defined that this is your I naught. See at t equal to 0, the switch is opened. Okay, t equal to 0, switch is opened. So the question is, what is I naught at t less than 0? So that is just before the switch is opened. Okay, assume that the switch was closed for a very long time. So just before the switch is opened, what is I naught? Okay. So just before switch is opened, right? That is, we are not at transient. We are before switch is opening. So when the switch is still closed, right? We are in steady state. So under steady state, how can we draw the inductor? Inductor is what under steady state? Is it open circuit or short circuit?
Short circuit.
Correct. So t less than 0, which means the switch is still closed. So as you told, inductor is short circuit. There is 8 ohms. This is our I0. All right. So what is the voltage? Sorry, what is the current I0? Very simple question, right? What is the current through the 8 ohm resistor? Okay, so how do I do this? There are multiple ways of doing this. Let's take the voltage to be some VA over here. So nodal analysis, VA minus 24 by 4 plus VA by 4 plus VA by 8 equal to 0. Okay. So VA by 8 is what we want, I0, right? So solve this, you will get what is VA. So
I noticed coming 1.2 amperes.
correct. I0 is 1.2 amperes. Yes, I0 is 1.2 amperes. Yeah, so minus 48 plus 2VA plus VA equal to 0. Therefore, you get 5VA equal to 48. So your VA will be 48 by 5, which is 9.6 volt. Okay. So VA is 9.6. Therefore, I0 is how much? 9.6 divided by 8, right? Which is 1.2 ampere. Got it? Simple question, right? Just recognize t less than 0 means we are at steady state. In steady state, inductor acts as a short. Inductor is basically short circuit under steady state. Okay, fine. We will go to the next. So is this problem clear to you guys?
Yes, sir.
Okay, great. So we will move to the next question. Again, a similar kind of a question. So the switch in figure has been used for a long time. And it opens at t equal to 0. Find V of t for t more than 0. And the circuit is something like this. This is your V of t. Okay. So the switch was closed for a very long time and it was opened at t equal to 0. Okay. So find V of t for t more than 0. So let's draw when t was less than 0, that is switch was closed, right? So when the switch was closed for a very long time, right? 60 volts, the switch was closed for a very long time. So you have 10K and you have 2K, you have a capacitor. So what would be the voltage if the switch was closed for a very long time? Right? We are at steady state. So under steady state, what is the voltage?
60 volts.
So, okay. So under steady state, capacitor acts as what? It is a open circuit. Correct? Under steady state, capacitor is a open circuit. So what is the voltage across the 2 kilo ohm resistor?
volts.
Correct. So V is basically what? You have to apply voltage division rule, right? So 60 into 2K divided by 10K plus 2K. All right. So 60 into 2K divided by 12K. All right. Which gives you 10 volts. So are you understanding this?
Yes, sir.
The capacitor will see what is the voltage across these terminals only. It doesn't know what is the DC supply voltage and all. It will see what is the voltage that is appearing across its terminals. That's it. Okay, it will just see from this view. It doesn't know whether it's 60 volts or 100 volts. It will see only what is the voltage across its terminals. Voltage across its terminal is what? Based on simple voltage division rule, you get 60 volts. Under steady state, under 10 volts. So under steady state, you get 10 volts across the capacitor. Therefore, your V naught is basically 10 volts. Did you get it till this point?
Yes, sir.
Okay. So now the point is when the switch is removed, right? That is when the switch is opened. So what does the equivalent circuit become? The equivalent circuit is now simply what? It is simply 2K resistor followed by the capacitor, because over here there is open circuit anyway. Okay. So this is 40 microfarad. This is V of t. Okay. We know that V naught is 10 volts. We just calculated it. V naught initial voltage across the capacitor is now 10 volts, right? So for t less than 0. So for t more than 0, initial voltage is 10 volt. This is an RC network. Therefore, so will the capacitor charge up or discharge? Now,
Discharge.
discharge. So the voltage will be what? V naught into e power minus t by tau. Correct? It is discharging. So V naught is basically 10 volts into e power minus t by what is tau? Tau is RC, that is 2K into 40 micro. That is 80 kilo into micro is milli. So 80 millisecond, right? 80 millisecond, or what is 80 millisecond?
0.08.
Correct. Or if I do 1 by that, I will be getting 10 into e power minus 12.5 t. Sorry. Are you getting this? Directly by inspection, I can write the answer. Okay, practice more and more problems. Okay. Practice a lot of problems.
Okay, sir.
See, by seeing the circuit itself, you should think, okay, when the switch was closed, right? I forget about the capacitor. I am under steady state. Therefore, this is the 60 volts with 10 kilo and 2 kilo. Okay. So I will be getting 10 volts across the resistor. Then I open the switch. When I open the switch, it's just an RC network. So the voltage will be what? 10 into e power minus t by tau. Answer is done, right? Directly you can think of the answer itself. Okay. Do more and more problems. But are you understanding how we did this? Is it fine? For t less than 0, draw the circuit under steady state. And for t more than 0, you again draw the circuit and find out. Is this question clear for you?
Yes, sir. Clear.
Okay. I think it is now almost time. So I think we can wrap it up for the day today. We will continue. There are just some 2-3 more problems in this. We will take those up in the next class and we can continue after that from there on. Is this understood? Like, for today's session, do you have any doubts or is this fine?
Fine, sir.
Okay. Okay. So thanks very much for hanging around and yeah, have a great
Hello,
week
sir.
ahead. Yeah.
Sir,
Yeah.
sir,
Yeah.
actually, last time I was filling the feedback form, but there is
Okay.
some issues with the feedback form, like some options were not visible, and there were some issues. So kindly check whether the feedback form is properly there or not. I guess other participants will also see some same issues. I guess some error messages were inside the options and some of
See,
this.
actually, the point is that I'm a teaching assistant. Okay, so
Okay,
I
sir.
am not handling the admin part of the work. Okay,
Okay,
so
sir.
I am not in a position to answer your query because I am not related to that. I'm just assigned as a TA for the course.
Okay, sir.
So regarding your exams and all, or exam or whatever is happening with your portal, I
This is
think you have to contact
the
directly the
exam.
NPTEL admin.
This is the feedback for this problem solving session, sir. I'm talking about.
Yeah. So all of those are actually floated by the admin side only, not from our side. So we don't
Okay.
have any say on that, or we don't have any communication with them regarding this. I'm just assigned as a TA for the course, and I do the TA ship. That's it.
Okay, sir. Thank you, sir. Thank you very much.
Okay,
Okay.
sir.
Okay. Thank you.
Good night, sir.
Okay, everyone. Good night. Have a great week ahead. Bye.
Okay.